Video, we're going to look at a type of reaction called an oxidation-reduction reaction. Essentially, an oxidation-reduction reaction is a chemical reaction which contains elements that change their oxidation number through the chemical reaction. So from one side, as the reactant side of the reaction, the oxidation number will be a specific number, and after the reaction has completed, on the product side, that same element type will have a different oxidation number. And so we're going to be looking at how oxidation numbers change, and this is essentially a movement or transfer of electrons. And when something is considered oxidized or is in the oxidation state, you are losing electrons, so you have gone down in electron number. This means that the overall oxidation number is going to be more positive. When something is going through reduction or is being reduced, then you're going to be gaining electrons throughout the chemical reaction. For oxidation number, this means you're going to be getting more negative. So let's look at the following chemical reaction and let's see if we can figure out which elements get oxidized and which elements get reduced. So in order to do this, there are a few rules that you need to know about oxidation numbers. One, that all elements in elemental form are 0 for their oxidation number. So Sn, here down in this chemical reaction, actually has an oxidation number of 0. So does H2 on the product side, because this is just elemental form of hydrogen. By itself, it has a 0. The next thing is that with oxidation numbers in compounds are that they tend to have the oxidation numbers based on groups in the periodic table that they happen to be in, and any element that happens to be a third element in a compound, there tend to be a little bit of exceptions to that group number oxidation value. So sometimes you might have to do some math in order to figure out what the middle element is in a compound. In this particular case, we have HCl and SnCl2. There is no third element in these particular compounds, so we won't have to really worry about that here in this particular chemical reaction. So what we'll do is we'll start out looking at HCl. For chlorines in group 7, so group 7s have a -1 oxidation number, and hydrogen is in group 1 and they have a +1 oxidation number. If we move over to 10-chloride, keep in mind that transition metals is another exception to using group number to determining oxidation number. Transition metals take the value that will give the compound in question a 0 total oxidation number charge. And so their value in oxidation number will be strictly based on what they're bonded to. So if we look at chlorine, chlorine is a -1, each atom of chlorine, but there happen to be 2 of them, so it's a total of -2 for all of the chlorines. There is only one 10 atom, so 10 must have a total of +2 in order to cancel out the charges of all the chlorines so that they sum up to 0. So now that we've found all of the oxidation numbers for our elements, what we need to do now is look and see if there are any that have changed from the reactant side to the product side. So it looks like there are 2. There is 10 Sn has gone from 0 to +1 or +2. And we want to determine essentially, is it oxidized or being reduced? And we go through and look at the definition of oxidation. So something becomes more positive and is losing electrons, that's considered an oxidized species. So we will say this is oxidized. And what is oxidized? That's the 10 element. The other thing that has changed that you can see is hydrogen. It has gone from a +1 on the reactant side to a 0 on the product side. And this is where we've gone more negative. Now the value is still, like it's a neutral, but it's not a negative number for the oxidation number. That's not what you're really looking for. You're looking for a number that has gone down or become more negative than what it used to be. So in this particular case, this is considered reduced. And the species that is being reduced, the way that you speak about this is the compound or molecule that holds the element that is reduced. So HCl in this particular case is the species that is reduced. So if we wanted to write this out, what is oxidized? The species oxidized, we say SN, and then the species that is reduced, that's HCl. Okay. So this is not the only way that you can kind of talk about an oxidation-reduction reaction. There are some other perspectives. Instead of talking about what gets oxidized or reduced, you could talk about what particular item is causing something to be oxidized or reduced. And in that case, we call these oxidizing agents or reducing agents. There is another kind of term that we can use for oxidizing agent, and oxidant is an example of that. And another term for reducing agent is reductant, and that's an example for that. So you may hear someone using the terms oxidizing agent or reducing agent, or you could hear someone using the terms oxidant or reductant. And essentially, an oxidizing agent is something that is reduced. Okay, in the compound that or chemical reaction we just saw with 10 plus HCl yields 10 to chloride plus hydrogen gas. All right. The thing that was reduced that we saw was the species HCl. That was reduced. So this would then be called the oxidizing agent, because it's what oxidizes what gets oxidized, which would be 10. The reducing agent is a species that is oxidized. Let's see if I've got an E there. And so since 10 was oxidized, then it is considered the reducing agent. So there's a couple of different ways you could talk about this species, but essentially it depends on your perspective. Do you want to talk about what happens to that element or compound, or do you want to talk about what that element or compound does to something else? Now, these reactions that we see here, where we have 10 going from 0 to +2, and hydrogen going from +1 to 0, sometimes we can write just the part of an entire reaction that is reduced or just the part that is oxidized. And these are called half reactions. So in this particular case, how you would do that is you would look at what is reduced, or sorry, we'll start with what is oxidized. And so since we know 10 is the oxidized species, how you would write that is you would pull out just the elements that are being oxidized from reactant to product side. So what I would do here is I would take my SN and I would put my arrow here, and then I would take my SN from the compound that it happens to be in and write it as 2 plus. And then what I would do is I would add the electrons that are lost. So you go from 0 to +2. That means you lose 2 electrons on the product side. And so we will place those on the product side because they're no longer in with the atom of 10. They are outside of that and will be transferred to some other element. If we are using the reduced half reaction, we would look at the part that is reduced. So we're going to go from the H plus and HCl to the H2. So we'll have H plus to H2, which has a 0 charge. Now notice how there are 2 H's. Half reactions have to be balanced also, just like regular reactions. So we would have to take our 2 coefficient and put that down here. Now where are the electrons going? Well, it turns out that the electrons are actually going to be put into the hydrogen atom, so they must be added on the reactant side. And so if you actually added these 2 half reactions together, you would show just the changes of oxidation numbers without including any of the ions that happen to not change. So in our particular case, this would just be chlorine ions staying as -1 charge. Now, writing half reactions are important, and it will become more important when we're looking at electrochemistry. But this won't be till Chem 2 later on, and so I'm not going to be having you write half reactions, but you will need to be able to understand what they look like and what they mean. All right, so let's try doing a few more examples. So let's determine if this number 1 is a redox reaction or oxidation-reduction reaction, and if so, tell me what is oxidized and reduced. So with this one, we're just going to go through and figure out our oxidation numbers. So we'll start with hydrogen as +1. There are 4 of them, so that's a total of +4. All the carbons must sum up to -4. There are 2 of those, so each gets -2. Oxygen here is an elemental form, so it is 0. -2 in CO2 is oxygen's oxidation number, and that makes a carbon would have to be +4 here. And then hydrogen is +1, oxygen -2 in H2O. So the changes here would be -2 to +4 for carbon. You're getting more positive, so that tells us that's what's oxidized. And then you have oxygen going from 0 to -2. And that means these are getting more negative, so that would be reduced. So what is oxidized? The species, that's what I'm referring to, the species oxidized is going to be C2H4. The species that is reduced is going to be O2. Now, if I asked you what were the oxidizing agent and the reducing agent, so if we looked at this from the different perspective, it's the exact opposite. Remember, oxidizing agent is the thing that gets reduced, so this would be O2, and the reducing agent is the thing that's oxidized, so it's C2H4. Okay. Let's go on to another example. We'll start with Fe2O3. Oxygens are -2. It's a total of -6. That makes each iron +3. -2 +2 for carbon. 0 for iron. -2 for oxygen and CO2. It'd be +4 for carbon. And keep in mind, whenever you have two nonmetals bonded together. The second element tends to use its normal oxidation number based on its group, but the first element must compensate for that. So it will typically could potentially take a charge that's not based on its group number. So we'll look and see what's changed. So it looks like iron has gone from +3 to 0. That's gone down in number, so that's a reduction or reduce. And then it looks like we have carbon is +2 to +4. So that looks like that's gone up in number. We call that oxidized. So the species that is oxidized is CO. The species that is reduced, that is Fe2O3. The oxidizing agent and reducing agent are the opposites. So Fe2O3 and carbon monoxide for the reducing agent. Okay, let's try another one. I wanted to give this example because I wanted to show you not every chemical reaction is a redox, but you're not going to know that until you actually figure out oxidation numbers. So let's try this one, and I'm going to show you why this is not a redox. So we'll do +1 for sodium is its oxidation number, -2 for oxygen. And so this ends up being a total of +2 for sodiums, -8 for oxygens. They all have to sum up to 0, so the one sulfur must be +6, right? So it's +6. Calcium +2, chlorine -1, +2, -2, same deal. Sulfur is going to be +6. +1, -1. So now look here into the oxidation numbers and see if you can find anything that changes. And it looks like, let's see, we have sodium is +1, +1. Sulfur +6, +6. Oxygen -2, -2. Calcium +2, +2. Chlorine -1, -1. Nothing changes in this. So you would say this is not a redox. You could say, though, it's something else. And this actually would be a double displacement and a specific kind that we would call a precipitation. All right. So I'm going to give you a couple more examples. What I would like for you to do is just pause the video right now, work through these examples, and then whenever you've got them worked out or you're wanting to check your work, go ahead and press play and your answers will show up. Okay, for each of these reactions, I show what is oxidized and reduced, and the value that they go up or down in their reduction or oxidation. Go ahead and check your work. If you have any questions, go ahead and contact me. You can come to my office hours, or I will see you in class.